Hello students, today I am going to discuss the term used to calculate the concentration. Write down the term used. At first, mass percent. Write down the headline. The term used in calculate the concentration. The first, mass percent. It is the ratio of considered mass and total mass in percentage of A, considered mass by total mass of mass percent of A is weight of mass of substance A in gram by total mass into 100, and weight by weight percent of B we can write in this form also, in gram by total mass of in gram into. This is the two formula we use to calculate the mass percent. Simply you have already read in class 9 also. And what is the use of this? Simply it is used in the titration. Titration is a method or technique in chemistry lab to find out the molarity or molality of the solution by known strength of solution to unknown strength of solution. And medicine sector. The next term is volume percent. Volume percentage. And similarly, we can write the formula of volume percentage of A equal to volume of A by total volume of the substance into 100. Volume by volume percent of B, volume of B by total volume of the substances. And what is the use of this? Write down. It is used in making alcoholic beverages such as cough syrup, beer, and other various components. Now next, mass volume percentage. Mass volume percentage. Mass volume percentage. It is the ratio of considered component and total volume in percentage. Of component by total volume into 100, and write down the uses also. It is used in child medicine, and making different solution. Now next, parts per million. Parts per million, or simply write in the form of ppm.
Semester 4 year of engineering.
By total into 10 to the power 6. Parts per million, or ppm, equal to mass by total mass into 10 to the power 6. Use of ppm, it helps to calculate the trace amount component present in air. Present in air or water. It calculates the trace amount component present in air or water, like percentage or how many parts per million of sulfur or sulfur dioxide or any component present in air or water can be calculated by this method. Now next, one question related to ppm. Write down the question. Chloroform present in water which is carcinogenic. Carcinogenic means cancer producing agent. In water, yeah, in nature, we can write down this also. In nature, if its level 15 ppm in water, calculate its mass. Its mass. So 15 ppm weight by weight percent into 10 to the power 4, or weight by weight percent equal to 15 into 10 to the power minus 4. So ppm equal to W by W percent into 10 to the power 4. Simple question and simple answer. We know that ppm equal to weight by component by total weight into 10 to the power 6. So W by W percent equal to weight by one component by total component into 100. So by this method we can easily calculate the component present in a water or nature by ppm formula. Traces, in fact traces of any substance in ppm we can calculate by this method. Now next topic is mole fraction. Next, mole fraction. Mole fraction is denoted by chi. Chi. It is known as chi. Just similar to the x, it is known as chi. What is the definition of mole fraction? Write down the definition. It is the ratio of considered mole and total mole, or it is the ratio of number of moles of a particular component to the total number of moles. Moles of the solution. Example, number of moles of the particular components. Number of moles, we know that given mass by molar mass by total number of solution of A and solution of B. Total number of the solution. The total mole fraction is equal to mole fraction of A and mole fraction of B equal to 1. Or if we find out the any one of them, 1 minus XA. So suppose in a solution moles of solute Na and moles of solvent NB, and A and NB. So total moles equal to Na plus NB, and mole fraction of solute, suppose XA equal to Na by Na plus Nb. So mole fraction of solute B equal to Nb by Na plus Nb. So simple method, sum of the mole fraction is always unity, and unit of mole fraction, we can write that it is a unitless quantity. It is unitless quantity. Remember it. It is unitless quantity. So what is mole fraction? Students, you can easily understand by this example also and easily solve the problem based on the mole fraction. Solve the question on the basis of mole fraction. 10% glucose present in aqueous solution. Calculate the mole fraction of glucose and water. At first, WA equal to 10 gram and WB obviously 90 gram. So, molar mass of glucose is C6H12O6 equal to 180 gram per mole, and molar mass of water, as we know, 18 gram per mole. So solve it at first. 90 given mass by molar mass by total mass, 10 by 180 plus 90 by 18. It comes after calculation 5 by 1 by 18 plus 5 and 5 1 plus 90 by 18. And 5 into 18 by 91 and 90 by 91, and mole fraction of A 1 minus 90 by 91. So solve it. 91 and it comes 1 by 91. So in this process you can easily solve the question based on the mole fraction. Now next, molarity. Molarity symbolized by capital M. Write down the points. Number of moles of solute dissolved in per liter solution called molarity. It is also known as concentration concentration, molarity equal to number of mole of solute and we can write NA also, and volume of solution in liter. Volume of solution in liter. And unit of molarity is mole liter inverse, or simply sometime it is written as a M also. It is temperature dependent. It is temperature dependent or increasing temperature molarity will decrease. Molarity will decrease. So remember this property. Next property, if density of solution is given follows formula is used. M equal to given mass by molar mass means number of moles 100 by mass of solution into density. Simple formula. Or we know that density equal to mass by volume, or we know that V equal to mass by density. If the solution is diluted, next condition, if the solution is diluted, then the following formula is used. Na equal to molarity into volume, number of moles before dilution equal to number of mole after dilution. So M1 V1 equal to M2 V2. This formula will be used. On mixing two different solution, next point, on mixing of two different solution, following formula is used. M1 V1 plus M2 V2 M3 and V3. M1 V1 M2 V2 equal to M3 V3. This formula is used when mixing of two different solutions.